Welcome back from that break, and you're still watching Digital Science for You. Now we get to head back to the lesson where you'll be learning plenty more. We will see you right after the lesson.
Each line is supposed to be on its own, and since this is north, they must be pointing in that direction. But when we are using digital science, if we can go back slightly to frame 413, you can see that the flux lines, they are not meeting anywhere. They are not crossing anywhere, which shows that it is more advantageous for us to use digital science as opposed to using our traditional way of handling the issues. Now, I talked about digital science being cost-effective and also being conducive for the teaching learning process. Because students, one, they enjoy looking at or using computers. Therefore, when you use digital science in your teaching, they are going, one, to love the topic or to love the subject, and also to be interested in the subject the more. Because electromagnetic induction, for example, is going to lead us into so many things. For instance, we need the light. We need electricity to provide the light. We need the electricity to provide to cook, or for our refrigerators, and so on and so forth. Therefore, if a student has learned about electromagnetic induction in more details, they can even develop a sense of the love for the subject, and therefore they can even generate so many projects concerning that topic. We normally use generators. We have different types of generators. There is a direct current generator and an alternating current generator. All these work on the principle of electromagnetic induction. Now, when we were trying to change the amount, the number of coils in 613, when we were trying to change the number of coils and also the rotation speed, you saw what happened. Now, these two can be manifested into what we now refer to as the laws of electromagnetic induction, which were put forward by a man called Faraday, and therefore we call them, or we refer to them as Faraday's first law of electromagnetic induction and Faraday's second law of electromagnetic induction. Now, the first law talks about whenever there is a change in the magnetic flux linked with the coil or the circuit, EMF is induced, and we saw that. We saw that by looking at animation 413, where the magnet, when it is moving into the coil, there was an induced EMF. Whereas when it was stationary in the coil, it was not producing or generating any EMF. So it only generates as it is moving in and when it is moving out, but not when it is stationary in the coil. Then the second law, you saw that when we went to the interactivity, we say it says the magnitude of the induced EMF depends on the rate of change of the magnetic flux. That one is clearly shown in that in the animation, in the interactivity. So that one is a way in which we can impart knowledge and interest into our students, other than boring them using the talk and chalk method, which is going to make them very disadvantaged, because you yourself as a teacher, you may find a problem in drawing diagrams on the board. But if you, the teacher, has a problem there, it means the students can have worse problems. And therefore, when they are answering questions in their examinations, there are certain things which they are not supposed to do. For example, as I said, these lines here are not supposed to cross each other. Once they do that, the diagram becomes wrong. Now, digital science plays a very big role in attracting the learners to pick interest in any subject. In physics, for example, after the learners have been taken through the digital science by the teacher, they can, on their own, once they are given the computer with the program, they can, on their own, go through it at any time of their convenience. And therefore, it does not need, or it does not mean that the student will only be responsible when the teacher is in class. But even when the teacher is out of the class, the student can go to the digital science and use it and learn more. Because it provides, for example, the recap. Once the teacher has gone through and wants to summarize the lesson, just click on recap, and it gives you a summary of what you have been talking about. And that one makes it much, much more convenient for the student to remember what the teacher did. Now, at the same time, digital science has got notes. Every topic that you teach using digital science has got notes. So you can refer to the animation and at the same time go to the notes. And in addition to the notes, we have the glossary and then the quiz. Now the quiz has got questions which have got answers and explanations. So for example, when you click on the quiz, you go to the learning mode or the test mode. Okay, just as I said, digital science offers a more reliable and interesting way of teaching the subject by offering a number of things. We said it has the notes, it has the animations, it has the quiz and glossary. And in addition to that, we have generated, as Cyber School, we have generated DVDs which have got questions, standard questions and answers. A student can attempt a full paper and then after answering can check whether he or she is correct by looking at the answers. So that is the beauty of digital science and virtual lab. I thank you.
That's been it from Digital Science for You. Now remember, Digital Science for You is the show, while Digital Science and Virtual Lab is the software which you can access via our main offices in Lugogo, via the UMA Show ground, and also students. You get to learn this easily. As for the teachers, you get to teach with no hassle. You can also follow us on our Facebook and Twitter. That is at CSTSUG. And you can also access us on those telephone numbers right below your screens. I've been your host, Nicholas Noah Trahubi. Until next time on that episode from another subject using digital science and virtual lab.